Okay, so this is question 2 in assignment 1 of MA359. 2 says, show that the Borel sigma algebra is generated by the family of intervals of the form negative infinity a in the real numbers. So this is the way we're going to do it. Let's call the sigma algebra generated by these sets, let's call it A, and let's call the Borel set B, the Borel sigma algebra B. Okay, so because the Borel sigma algebra is generated by all the open sets, and all the sets in A are open, clearly A is inside the Borel sigma algebra, right? Because the generators of A are a subset of the generators of B. But to show the inclusion in the other way, we just have to show that all the open sets are in A. Then the elements in A will generate B, and so they're equal. Okay, so how do we do that? Well, we want to show that there's an element of the kind A comma B in A for all A comma B in the real numbers. Okay, so clearly we can find an element like negative infinity comma B in A. So for any B, so given any B, you can find this in A. So given B, then there is this negative infinity B open set in A just by the definition of A, right? It's just one of the generators. So now we want to, let's try to get the other way, let's try to get this A bit. So let's let A be less than B, real number. And because A is a sigma algebra and is closed under complements, we know that this element, which is the complement of infinity comma A, this complement of this set is in A. This is the complement of an element in A, so this is in A, so that's good. But this is going to be in A, you know, even if we just add on something, and that's what we're going to do, we're going to add on something, and what we're going to add on is 1 over n. So we're going to look at the set A plus 1 over n, comma, infinity, intersect negative infinity B, which is this one, right? Okay, so why are we going to look at this? Well, because A is closed under intersections, this whole thing is going to be in A. And because this is in A, any findable union of these is going to be in A as well. To just simplify this here would be A plus 1 over n B, taking the intersection. But then we can take the union over these, right? And this would also be in A, because, you know, countable unions. So, but what is the union? Well, this will contain every element bigger than A eventually, because as n gets bigger and bigger, we can get numbers closer and closer to A from the positive direction. And we can also get every number less than B as well. So eventually this is going to be equal to A, B. And so we've shown that A comma B is in A, and this concludes our proof. There's maybe a little bit of a slight thing you might ask. What about, for example, A infinity? Is that in A? And yes, it is. Well, we can, because A infinity would just be the union, and so it's just a union of elements in A, a countable union of elements in A. So we're done. Thanks for watching.